So in this is a question on application of differential equation. So again, the rate of decay of a radioactive material is proportional to the amount of such material present. If it takes 5 years for a third of the material to decay, find how long it takes for half of the material to decay. So let X be the amount of radioactive material. Radioactive material present. Alright, so the rate of decay would be d. That means they're saying rate of dx dt is proportional, so k, to the amount of such material. Again, we have defined it to be x. If it takes 5 years for a third of the material to decay, so when x when t equals to 5, we are left with 2/3 of what is there in the beginning, right? A third. Alright, so let x0 and x0 be the amount of material initially. So 2/3 when t, that was the initial amount. So find how long does it take for half of the material to decay. So what we want to find is x. So that means what we want to find is the time when x equals to half of the initial amount. Therefore, we start with this differential equation, and then we will bring 1 over x integrate dx equals to integrate k dt. So multiply dt over and put an integration sign, divide x on both sides, and just put in different equation sign again, and then we will have ln mod of x equals to kt plus c. Alright, this is when we do integration. When the derivative is when top numerator is derivative of denominator, we always just ln modulus of the denominator. And but in this case, since mass of amount of such material cannot be negative, this modulus is negligible. At least we can put a round bracket instead of using the modular sign, since it makes no difference. And then here I can put an exponential on both sides. I'll get x equals to ekt plus c. And then we will have a common mistake made by students is they will write this akt plus ec. That is wrong. Alright, you cannot do that because it's algebraically incorrect. So then we will have this will be ekt multiplied to ec, right? Notice this is power rules. Alright, am plus n equals to an multiply an. So exponential is just a constant anyway, so we have to follow the same rules. And ec, we can let it be aekt. So that means a equals to ec, and c is just an arbitrary constant. So then we'll have we just check what is when t equals to 0. So what this one, we define it as x0. So then when t equals to 0, so that will be a, right, equals to x0. Therefore this equation can just change to x equals to x0 ekt, right, like this. So find how long does it take. So then we have this equation, so then we will make use of this to find what is our k. So since x when t equals to 5, where x when t equals to 5 is just x0 e 5k, correct? Yeah, 5k. So then equals to 2/3 of x0. I'm just using this equation, and then substituting t equals to 5 into this equation. So then this one x0 would cancel, we'll divide x0 on both sides, so then we'll have e5k equals to 2/3, and that is just 5k equals to ln 2/3, and that is just k equals to 1/5 ln 2/3. Okay, so that would be my k. So then what is my, then substituting this back to the original, like then the equation, so we have x equals to x0 e 1/5 ln 2/3. Alright, 1/5 ln 2/3 is just my k, and multiply to t. Okay, so this 1/5 could become the power of, using the log rules, so this would be ln 2/3 to the power of 1/5 on entire thing, then multiply to t. So this e and exponential would just cancel off. Okay, so leading to, in fact, right, this t could also go to here, right? So we could just write this t here, right, because they are multiplied, and then we have this missing, then we have the t on top of as the power as well. Then e and ln will cancel off, and so we have x0 2/3 t over 5, right? That is the, so we want to know how long does it take, what is our t. Okay, so we will calculate this, and that is just we'll try to find t. So what, so x0, when x equals to half x0, so I'll just replace x with half x0, and then we have x0 2/3 to the power of t over 5, and x0 will cancel away with x0, and we will have half equals to 2/3 to the power of t over 5. And to find my t over 5, I use the ln function to get the t over 5 down, and then we will have what my t is just 5 ln 2, 5 ln half over ln 2/3, and that will give me, do a calculation, what's that value, by ln 0.5 divided by ln 2 divided by 3, and that will be equals to 8.547 or 8.55 years if I round it to 3 significant figures, and that we got the answer here. And so that's for this tutorial.